The first thing I wanted to point out was in this session, we're going to be talking about how to build apps using the Report and Dashboard API. This was the feature that we launched last year called the Analytics API at Dreamforce. And one resource that I want to point out at the beginning of the session is our cheat sheet. So this is a 2 to 3 page cheat sheet that's going to contain all the resources with simple code examples on how you can start building the application. So quickly back to slides. My name is Arun. I've been a product manager at Salesforce for a couple of years. I've been with the Salesforce Analytics group for 6 years now. Your favorite safe harbor slide. We'll probably be discussing only features that are available right now. And please make purchasing decisions only based on current products. So what is this Report API? Winter 14, we launched a brand new API for reports. And our whole goal with this was that all the reports that are built in Salesforce contain valuable information. So all of these are user-generated reports that contain key metrics. But one constraint was that all these reports could be accessed only within the standard Salesforce UI. So it was not previously possible to maybe build a custom application that takes advantage of all the effort and all the IP that has been created by all the admins and analysts in your organization. With the Report API, it's going to be incredibly easy to start consuming all of these pre-built reports. And to just give you an idea of the number of reports that exist, overall, there are over 45 million reports that are in the system that have been created by users, and over 10 million of them are being run very actively every month. So if you're thinking about building, say, analytic applications, then this is going to give you the opportunity to reuse most of the content that's already been created and already being used in your organization. One of the ways the Report API say is different from other forms of accessing your data like SOQL is that the reports act as a layer of abstraction. So the way you could think of it is you could build a completely metadata-driven application where the data sources are reports, and your end users can now modify those data sources without actually making changes to the application. So just to illustrate the point, let's say you have a simple table. You're generating a simple table, and then the data source is a report. And a week after the app is deployed, one of your users comes back and says, I don't want the data. I want to have a few more columns. Maybe I want it segmented by product instead of region. Typically, what would happen is this would turn into a change request. And the developer has to go in, make the SOQL changes, test it, deploy it. And it's kind of troublesome in two cases. One is developers who should be focused mostly on innovation and new applications are now spending maybe 30% of their time doing change requests. And for the end user, they don't feel empowered because every time they need a change, they need to come to you, they need to ask for the change, they need to justify why it needs to happen. With the Report API, the way we are trying to address the problem is developers can build completely metadata-driven applications in the sense that the results that come from every single report is going to look semantically the same. And for the end user, it's very convenient because they already know how to build reports, they already know how to modify reports, so they can very easily go in and make the changes that they need without even bothering the technology folks. One of the things we did when we originally launched the Report API last year was we came out, we discussed a lot of things, and we had a number of questions that frequently come to us. So I just wanted to quickly go over those common questions before we jump into the demos. First one is questions on visualizations. So some of the first 5 or 6 examples that we marketed when we launched the API were around visualizations. I'm going to be showing you an example of building fancy charts today as well. So the first question is there anything I can do beyond visualization using the Report API? It's a standard REST-based API, and there are actually pretty complex applications that you can build on top of it. One application that I do want to point out is the sales management application built out by the Task Group. Task Group is an ISV of Salesforce, and they were one of the early pilot partners in the Report API. And what they've done is they've built a sophisticated sales application. So this app is going to tell you what is your current bookings and what is your current billings. And all the data sources in the backend are basically Salesforce reports. So this is just to prove the point that This goes above and beyond visualizations. You can build fairly custom applications with this. Second question we get is, I am not a developer, I'm only an admin, or maybe I don't know how to use REST. Other examples, can I try out the report API without actually spending development time? The answer is yes. What we have did is we posted an application called MyCharts. So MyCharts is an open source application available on AppExchange. It was built by one of our engineers internally. And what it does is it gives you a way to look at your Salesforce reports using Google Charts. So this is a very simple, nice app. You can just go install, see how it works. And all of the source code is available on Visualforce as open source. So you can feel free to extend it and try out the application. Additionally, I also have a number of examples posted on my blog. And this is my GitHub account. So most of these are simple Visualforce pages under, say, 30 or 50 lines of code that you can easily copy-paste and then replace the report ID, see what kind of apps you can build. The third question is limits. The report API does have limits. And the two main limits are the data size and how often you can run reports. So in terms of data size, the report API returns only 2,000, and it does not have any semantics like query more. The second one is you can run up to 2,000 reports an hour. And this is a fairly high number if you think of the number of analytic queries that are being performed. But at the same time, if you're building a high-volume application, say that's targeted towards support desk agents, then 2,000 per hour is not going to scale. So definitely this is something to think about as you're architecting your application to say, does this limit even work for me? The last was Apex support. Since we call it the report API, since we market it as the report API, often the assumption is there's only REST API support. I do want to point out that as far as the reports go, it also has Apex support. So right within your Apex code, you can run a report, get the results, and then post-process it. As far as dashboards go, we only have API support as of right now, and we're going to be working on Apex support in the future. So on that note, I want to quickly jump in and show you a couple of demos. You can feel free to interrupt me if you have any questions as we're going through any of this. The first example that I want to show you is how you can take a Salesforce report and then visualize it as charts. The use case we're going after here is you're a support desk manager, and you want to highlight the key metrics on a big screen TV. So what you really want is you want real-time metrics that are auto-refreshed, like a dashboard, that your team can follow and work towards. Let's first look at the demo to see how the results look. So what we have here is we have a couple of charts. Like I said, both of these charts are being sourced by Salesforce reports. In the background, I'm using the REST API to run these reports, fetch the results, and then display it using an open source chart engine called D3. So we can look at the code very quickly. So the first three lines are the libraries that we need to actually run the application. The first one is your standard jQuery, which is used to make AJAX request. And then I download the D3 and the NVD3 chart engines. So NVD3 allows you to build interactive charts like these very easily. If you don't make it auto-refreshing, you can actually build some very nice drill-in capabilities. So a little bit of interaction and exploration is possible. The first step in the process is to run the report. And all of our reports and dashboards are under the analytics namespace. So you can see that under services, data, version, you have the analytics namespace. And under that, you have reports and dashboards. The way you would run a report is basically make a call to /reports/ whatever the report ID is. And in the background, it's going to run the report and send you back the data all as a JSON object. Next step is we add the authorization header just before running it, and the results come back as a response object. So the main thing to understand about the response object for reports and dashboards is the data structure looks more or less the same. And the way it's structured is the results come in two portions. So the first portion is an array of dimensions, and the second portion is what we call the fact map. The fact map contains the results. So if we go back to, say, a sample report, this would help me explain it better. So what I mean by dimensions is it's your typical group by clause. So this matrix report, which looks like a pivot table, is basically grouping by case origin and case type. So what the result set is going to contain is it's going to contain a list of dimensions, which is going to be an array of email, phone, website, and so on. It's going to contain another array of the across dimensions, which is technical issue, usage, installation. And what the fact map is basically this table right in the middle. The way you would look up a result in the result set is you would say, what is your dimension on the x-axis, what is your dimension on the y-axis, and then you would go to the fact map and say, give me the corresponding result set for this dimension. It's kind of looking up data in a cube structure, and that's what we're doing here. So what we're doing is we're going to each of the down groupings, and then we're going to each of the across groupings, and basically saying, give me the down grouping key, and give me the across grouping key. Once you have both of the grouping keys, you're going to pass it on to the fact map, and then ask for the list of aggregates. And then once we have the aggregates, what we're going to do is we're going to populate a data structure called the chart data object. So the chart data is a very simple two-dimensional array. So it's basically an array of keys to values. And by key, what I mean here is it could be email, would be the key, and then this would be the array of values. And the array inside is basically technical issues 4, usage is 0, that kind of a table structure. Once you have populated this chart data object, what we do is we pass it on to D3. D3 is a very interactive animated charting engine that's available for free. So it's definitely getting popular, and if you're thinking about visual apps, this is definitely something to look into. You just pass it into D3 to say, here's my div ID, here's my chart data, go draw the chart. And what D3 is going to do is just draw the chart. Since we wanted to have multiple charts, I just put this entire code into a JavaScript function. I have a couple of SVGs here, which are basically containers for the chart. And then this is the report ID that feeds the data. So here the main thing to note is that the first report is getting you case data. The second report is getting account data. Technically, you could take all of the code that's right here and plug it into any of your reports. So the application has no context on what query it's working with, what is the result set it's working with. All it knows that it's working with a matrix result set. So in this example, again, you see that the first chart is coming from this report, and the second one is from the other report. And let's say I've built the application, I've deployed it for my users, and then the manager wants to look at a different set of metrics. Maybe he doesn't want to look at it by stage and type. He wants to look at it by stage and lead source. All he has to do to customize the application is basically modify the report, hit save, and the moment you come back to this page, you're going to see that it's automatically going to be updated. So it's no longer by lead source, it's updated to be by, it's no longer by byte type, it's by lead source. So the idea is you would build your app with code, but it can be easily customized by any of your users with clicks. Any questions? So I'm going to quickly move on to my next demo. So this one is going to be using the Apex version of our report API. So in this application, what we're trying to do is we're going to run a report using the API, and then we're going to take the result set, and using the result set, we're going to make chatter posts. So the use case for this one is, here again, you're a support desk manager. You want to make a list of accounts, find out which accounts have cases that are beyond the SLA, and then you want to post a message onto the account's chatter feed to basically say that this account has cases beyond SLA. Somebody please look into it. The application is fairly simple. What we have is a simple Visualforce page that is going to accept the report ID, which is your data source, and the message that you would like to post. So this is all the page is, and it's fairly simple. We have 2 input boxes, one for the report ID, one for the message, and one action which basically does a post. If you look at the Apex class, this again is fairly simple. Here you see that I'm passing in 2 arguments, which is the report ID and the message. Once I receive the report ID, I'm going to use the report manager class to run the report, which is going to synchronously run the report and return back the results. Once I get back the results, I know that this report is being grouped by an entity. It could be user, it could be account, it could be opportunities, anything for that matter. Here again, the thing I'd like to point out is it's completely generic. So this piece of code has no context on its posting messages to a case or it's posting messages to an opportunity. We go through each of the groupings, the same concept. We get the fact map key. We get the aggregate for that. So what we're trying to do is we find out how many cases are open, and then we create a feed post item, and then we just post the message. So let's go back to this report. We can copy the report ID, and then open the Visualforce page, say paste it, and then say, oh Lord, this account has too many. So when I hit post, what's happening is in the background, we run the report, we get the result set, and then we are going to post to every entity that shows up on this report result, the chatter message that I just mentioned. We can quickly open chatter to make sure that this exists. So it's fairly simple. The main thing here is that even though this application is fairly simple, this can be very easily expanded to a large number of use cases. So you could pass on this Visualforce page in Apex class, which is under 50 lines of code, and then you could imagine this being used by somebody in sales operations. So they could build their report to make a list of people who are entering bad data, like closed dead in the past, and then they could use it to say, go post this message. You could imagine having it in engineering organization. You know, a developer manager can go and say, you have too many open bugs, go fix it. So the main idea is that the application is very abstracted from the data source, so to speak. So that is the main advantage of here. Any questions?
Yeah. So you mentioned about the facts and dimension type of query, but there will be some queries which may not be facts and dimension oriented. It may be just like joins or outer joins and grouping, having class, that type of reports. So how to generate that type of reports in the API?
Good question. So the way the API works is you build all the reports using the standard Salesforce UI, and you can consume the report results using the API. So the API is very simple. It's just one endpoint. You go say /analytics/reports, pass in the ID, and it's going to give you back the result set. So it doesn't matter how many objects are behind the report. It could be a simple report, like you said, with a list of cases. It could be a much more complex report that is spanning across multiple objects and then has 2 or 3 levels of groupings. As far as the API is concerned, all of the results look the same format. So I'm not sure if that really answers your question.
To answer the question, so that means if I have to use this API, then the report can be configured first before the API is called?
Absolutely. So the reports have to exist. So there are a couple of things you could do. One thing we've seen some of the ISVs do is, along with the application, like the Apex code and the Visualforce page, they also package a set of reports that act as data sources, and then they give it to their end users to say, if you want to customize the application, go modify these 4 reports. Please go ahead.
So if you're going to use this to make updates to the objects themselves, is there a way in Visualforce to identify
Right now, the report API doesn't give you a handle to the individual object rows. It's because unlike a list view, a report can span multiple objects, and the same row might be referring to each column in the row might be coming from a different object. Each row does point to an object, but we don't have that metadata. The only workaround right now is you could include the object ID and then try to infer it. But yeah, that's what we have. So that's very quickly both of the demos that I wanted to show you. Again, back to the cheat sheet. Similar to the reports API, last release we also launched an API for dashboards. The idea behind the dashboard API is all of the result set and the format, the fact map, and the dimension array, all of it look the same. So if you have an app that is built to use reports as a data source, you should be very easily able to use a dashboard component as a data source as well. In addition to just extracting data from a dashboard, the API also supports refreshing the dashboard using the API. So one case we always hear is people want to constantly refresh their dashboards. And there's no mechanism built into Salesforce to do that. But with the API, you could have a process that regularly refreshes the dashboards externally as well. So that's all I had to share with you guys. Thanks for coming.